one of the applications of this counting idea has a lot to do with security, especially on online platforms, because we need to write a password so many times when we enter into something, and you don't want somebody else to know or guess your password. So in order to determine how strong a password is, usually it's based on, well, how many passwords are possible? How hard would it for me to guess your password based on a certain length? So here's an online banking account which says they want 2 letters followed by 5 digits. And most of you, by now, when you go to make a password, this would no longer even be allowed. They like have a minimum of 8 before you can even make your password. So if we were trying to count how many passwords were possible in this situation, we first have to say, well, how many decisions need to be made? And since the password is going to have 7 things, that means we are going to write a space for each of those 7 decisions. And underneath the spaces, to sort of explain what our decision is, we often write something small. In this case, I'm going to write letter, letter, LL under the first 2 decisions to remind myself those need to be letters, and then digit, 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 digit under those decisions to remind myself they have to be digits. Now, this question isn't completely clear. You need 2 letters. Does that include lowercase and uppercase, or just a letter? Right? So, and then which language are we using? Are we using the English language? Well, probably, because the question's in English. How many letters are there in the English language, in the alphabet? 26, right? Different languages have different amounts of letters, right? And so we're doing English here, we're only going to consider 2 letters, not uppercase and lowercase, so then we'd have 26 choices there. And it says you're allowed to use it again, you're allowed to repeat, so there'd be 26 choices there. How many digits are there? 10, right? 1 to 9 plus 0 gives us 10 choices there, 10 choices there, 10 choices there, 10 choices there, 10 choices there. Okay? And if we multiply these all together, we get 67,600,000. I'd now like you to list them all. No, just kidding. That would be terrible. That would take not forever, but pretty close. So your chances of guessing the password correctly are not very good, right? 1 in 67 million. But now our passwords are even bigger, and on some websites, right, if you keep guessing a password, eventually it says, I see that you've guessed 3 times already. You only have 2 more tries before we lock this account, which is a nice security thing, except when you're the actual person trying to get in, and you're like, I cannot remember my password. Usually what happens to me is I do know the right password, but I make a typing mistake the first time I type it in, and then it says password wrong. So you're like, oh, did I use a different one of my passwords? So I try my password number 2. No. How about password number 3? No. And then it's like, you only have 2 attempts remaining. I'm like, oh no. So there are ways that passwords, right? One of the ways that you can break into a password is by having so many different combinations possible that it's hard to guess. Then they have other levels of security as well. Okay, so questions to do for this one. 5, 7, 8, 9, 10, and 16.